Hi, my name is Jamie Gillespie, and welcome to the APNIC Vulnerability Reporting Birds of a Feather session. Good? Cool. Hello, everyone, and welcome to the APNIC Birds of a Feather session for Vulnerability Reporting Management. My name is Jamie Gillespie, and I'm going to be presenting during this session. So the presentation that I'm going to be giving today is looking at APNIC's Vulnerability Reporting Program, looking at insights that we've gathered from the creation of this program and through the first year of operations. So just to give a little bit of background, most of you are aware of APNIC, but just to set the scene for how we are as an organization. So of course, we're the regional internet registry. We cover 56 economies that make up the Asia Pacific region. We distribute and manage IP addresses. We operate as a not-for-profit organization, and we operate purposefully open and transparent in everything that we do. We have approximately 120 staff, most of them based here in Brisbane, Australia. We're operating with multiple data centers in Australia and internationally. We use infrastructure as a service hosting on both AWS and Google Cloud with multiple SaaS applications and vendors. And it's not just websites that we're hosting and running and making public, but we also have other services as other companies would, VPN, SMTP mail servers, DNS servers. But we also run some infrastructure that isn't as common on the internet. So we are running a public FTP server on purpose. We run Whois servers, of course, for accessing information about IP address maintainers and allocated network operators. And we're also running our PKI-related service and servers. So that does give us a little bit of a unique profile. So in the beginning, we have a very public help desk, and of course we still do, helpdesk@apnec.net. Many of you watching this session would have probably interacted with helpdesk already. It's used for member inquiries, and it's pretty much a catch-all email address for contacting into APNIC for any member or general inquiries. Now, we do have an old security@apnec.net email address. This email address was created and used for the IRT contacts as part of Whois records. And this was used as the default IRT or abuse contact for IP addresses that had been allocated to the Asia Pacific region, but have not been allocated to direct members yet. Now, this picture below is from a presentation that was done in 2011, shortly after security@ was used for IRT contacts, and IRT contacts were becoming mandatory. And you can see that in 1 week alone, the security@ email address was receiving over 4,200 spam complaints alone, along with hundreds of other complaints of other types of internet abuse. Now, a lot of these complaints would not have been accurate as they were being sent into our contact address, largely for IP addresses that hadn't been allocated out. So they were probably from spoofed or otherwise forged addresses. So internally, APNIC has an internal IT team, as most organizations do. Actually, we've got 2 of them, but they work very closely together. On the security side of things, we were performing internal vulnerability scanning, and we were contracting in organizations to perform external penetration tests. Again, fairly standard, standard best practice for organizations to be doing. Now, we also have developers internally that are writing new applications and code, some of it being used internally, some of it being used externally on the servers, services, and websites. And we had the APNIC Computer Security Incident Response Team, or CSIRT, created, and that was created for internal operation and formalizing the security incident response procedures and just overall information security work. Back at this time, APNIC was starting its journey towards becoming certified for ISO 27001, and there was a lot of work being done under that. So it was done under the banner of the APNIC CSIRT for internal security work. Now, we had some early vulnerability reports that were coming in even before the CSIRT was being formalized for internal work. Now, without a proper security point of contact that was advertised to the world, security researchers and anybody who found problems on our servers and services would email any email addresses they could get a hold of. Some were going to help desk, but some were going to privacy@ or even HR@, and that's for human resources. Now, of course, these are still people internal to APNIC. They can still share this information around to us, but it seems like spam messages to them. So a lot of them were being ignored or took a very long time to be routed to the right people. Now, as an example of an actual scam email, this is another one that came in. The text saying here is that somebody found vulnerabilities or bugs on our website, something about the privacy of login. It's a big error. And if you pay me money, I will tell you what the vulnerabilities are. Now, we know that this is a scam for sure, because if you actually take some of the text from this email and do a Google search for it, you're going to see a lot of people that have received this text and a lot of people who followed up. And yes, it is just a scam, someone hoping to make a quick buck by just asking for money, essentially. So this led to the conception of the Vulnerability Reporting Program. So we discussed that we should have a point of contact for security researchers to contact us directly to the IT teams for the proper response. But when we thought about creating a contact, we would need to advertise it somehow. How are we going to get the message out that this is the email address to use for contacting us? And if we did put that message out, we need to set some rules. Why or how should people contact us, and for what reasons? So we want to let them know, contact us about APNIC infrastructure ourselves, Don't contact us for problems with our members, for example, or for routing issues. That's not what this purpose is for. So if we're setting up an email address and we're advertising it and we're setting rules around it, it's sort of sounding like a bug bounty program. At the creation of this, bug bounty programs were popular with the very large multinational for-profit organizations. Google had been running their vulnerability reporting program for many years at this time. Even organizations like Tesla were running them for people to try and report vulnerabilities. But these bug bounty programs were offering a bounty. It was a financial incentive for security researchers. So we thought, well, we won't be able to pay out bounties like these big profit-driven companies can. So would a bug bounty program work without any bounties? And that was the real question. And we weren't sure if it would work. We weren't sure if any security researchers would even report issues to us without that financial incentive. So we put some work together. We decided that we're not going to be offering any bounties. We don't have to put any money towards it. It's just going to be operational effort for it. And this was the start of the APNIC Vulnerability Reporting Program. Now, externally with other organizations, this is sometimes called a Vulnerability Disclosure Program, or VDP. At the creation of the program that we were doing internally, it was about 50-50. 50% of organizations were calling it a vulnerability reporting program, 50% calling it a vulnerability disclosure program. We went with reporting program as other organizations were using disclosure programs for disclosing vulnerabilities out publicly, as opposed to having external security researchers sending them in. So we went with reporting program, but the name doesn't matter too much. So one of the ways that we started off was reading a lot of text from other vulnerability programs in order to see how they were wording it, what changes they'd gone through over time, and using best wording from a lot of different organizations, as well as putting our own unique spin on it to create a draft reporting program. This draft was circulated across our IT teams for feedback and improvement, went through a few different iterations, updating it, making the wording a little bit better, and making it purposeful for APNIC's unique situations. We also used an early template from disclose.io. And this was a template for the safe harbor language. The safe harbor language is being used to basically tell security researchers, if you report a vulnerability to us properly, we will not send our lawyers after you. We won't try and sue you. And this was becoming a large problem as there were a few high-profile incidents where security researchers were doing the right thing with other companies. They were contacting them, they were telling them about vulnerabilities they'd found, and those companies had actually sent legal notices to them telling them that they were being sued for illegal breach of their systems or illegal activity on their systems. It got to the point where a lot of security researchers were actually having a chilling effect on them so that they were no longer reporting security vulnerabilities to companies that didn't have a vulnerability program. Some other security researchers were going through extreme lengths of using VPNs and Tor and other anonymizers and anonymous email addresses in order to still report this information to make these organizations more secure, but to shield themselves from legal action. Now, disclose.io was a great resource for us to start off with. They've actually grown since then. They now have an entire vulnerability disclosure program generator and templates that you can use. So if you wanted to go through this process now, I would recommend disclose.io as a first point of a call to look for that. Now, after we drafted everything up, we got the language that we wanted from disclose.io. Of course, it was a bit Americanized, so we passed all of the information through the APNIC legal team for them to have a review. Not just the safe harbor language that needed to be updated for Australian laws, because that's the legal environment that we operate in, but also just the vulnerability reporting program overall, making sure that the legal team was happy with how it was being set up. So going through the layout of our vulnerability reporting program, I've got a link for it later on, but it has changed over time. So this is the way that we started off the vulnerability reporting program text itself. So we were putting this up as a web page, and we started off with a section talking about the background of APNIC, who we are and what we do, so that anybody who's reading it has an understanding of the organization. We did an introduction of the VRP that we just called bug reporting. So we got that up nice and high so that people understand the purpose of this document. A little bit of text that quoted from it here that we value the hard work of the security research community and welcome responsible disclosure of any vulnerabilities in our products and services. Now, the keywords here are responsible disclosure. That should trigger a lot of security researchers to know that they need to report things to us privately and not publish the information without talking to us first. So that was really useful. And we detail out that what exactly that means later on so that there's no assumptions. We let them know that we wanted them to use the cert@apnic.net email address. We did a basic email obfuscation that you see there with the @ sign replaced with AT with square brackets around it, just to give a small attempt to reduce the amount of spam that was coming to that email address. And it seems to have worked so far. We also included an optional section where if security researchers wanted to encrypt their email messages to us, we created and published a GPG public key on the site. And we're also setting their expectations. You know, we said that we aim to reply to all reports within 7 days, and we aim to resolve reported priority 1 to priority 4 vulnerabilities within 90 days. Now, this was a bit of a trade-off. We want to make sure that we set the expectations to the security researchers so they don't think that we've gone silent, we're not working on the vulnerability, and they go and publish it before we've had time to mitigate the vulnerability. But we also wanted to make sure that we set the boundaries wide enough so that we're not putting undue stress on our security teams, our IT teams, and our product teams that may have to work on fixing the vulnerabilities. So we agreed on 90 days, and that seems to be the higher end of the number for a lot of vulnerability reporting programs. And priority 1 to priority 4, working on a 5-point priority scale. Priority 5 would mean things that were just informational, not really a security vulnerability, maybe just something that wasn't configured properly, but not an actual vulnerability with a security impact. So we're basically saying within 90 days, we will fix any valid security vulnerabilities. Obviously, the higher priority ones get fixed much shorter than 90 days. So next up, we defined the scope. And this was great. We actually went ahead with a very broad scope. And as you can see here, we actually put wildcards. We want to know about any security weaknesses or vulnerabilities on any system that ends in the APNIC managed domain names. So that's apnic.net, .foundation, ISIF Asia, Seed Alliance, and even the more recently created APIDT. So we didn't want people just to focus on our websites. We wanted them to go across everything and find those weak links that we may have that, you know, sort of get swept under the rug, as you can imagine, over the years and years of operations. Now, after an in-scope section, we made sure to put an out-of-scope section. So we start off with wildcards, very broad, and then we limit it a little bit. First off, we got this wording from another vulnerability program saying that we exclude third-party sites. So some of the SaaS applications that we use, like Okta, Cloudflare, Zoom, Microsoft 365, those are excluded because we can't give permission for people to attack their systems. So they are out of scope from trying to find vulnerabilities on those systems. If they stumble across something accidentally, they can report them to us and we'll send them through and see what we can work out with those organizations. But please don't target those companies without their permission, at least. We also put out of scope as destruction of data. We don't want anybody trying to destroy things in the purpose of testing our systems in case any of their attempts are successful and, completely dropping an entire database. That would be a bad thing. We don't want anyone testing for denial of service or distributed denial of service attacks. Obviously, a lot of our systems have DDoS protection mechanisms in place, but some of those protection mechanisms are better than others. And obviously, if you send a large enough volume of traffic, you may overwhelm one site on its own. So nobody is completely protected against the largest DDoS attacks that can be created. And we just don't want people attempting any of that against us. We also don't want people attempting social engineering attacks. Social engineering is a known issue. We go through many layers of protection, and we don't want to flood our staff members with a whole bunch of social engineering attacks, either directly on their APNIC email addresses, but we also don't want security researchers hunting down Facebook accounts for our staff and trying to do social engineering attacks that way. We want to focus on actual security vulnerabilities. And last but not least, we don't want people coming to the office and throwing a rock through our windows saying that our windows are not secure. So physical security controls were also in the out of scope section. So relatively short list that we started off with here. Further down in the reporting text, the program text, we repeated that we want people to use the CSERT@ email address to send things in. We gave a quick list of the types of details that we would want reported in. So this is for the more novice or beginner security researcher who may not know how to format an email for sending us a report. So we give them a few points to get things started on their email structure. And at the bottom, we put in a message quoted here: as a not-for-profit organization, we can't pay out major bounties, but we really appreciate this help in safeguarding our systems. If we confirm your finding as a vulnerability, we can recognize your contribution in the thank you section below. So this actually wasn't the very first set of text, but it was edited very quickly. We did put in a thank you, or sometimes called a Hall of Fame section. And this is where we can publicly acknowledge the security researchers that have been helping us out. And for a lot of the novice security researchers, getting this public acknowledgement helps them build up their resume as a security researcher. And then at the very bottom is the safe harbor language. So I was talking about this one before. I've summarized it here into 4 points. If you conduct vulnerability research that is in scope, and you report the findings to us in a timely manner, we will consider these acts as authorized and promise not to take legal action against you. And again, this statement is really powerful so that security researchers have an assurance that we're not going to send legal notices to them. Next, we generated and published the GPG key that I mentioned before. And as part of that, we also created a security.txt file. This was created with the website securitytxt.org. It is just plain text, so you can create it on your own, but securitytxt.org helps you make sure that the formatting is correct. And this is very similar to a robots.txt that have been around for many, many years that direct web crawlers and search engines to know what parts of your website to crawl and which not to. So security.txt, you can see the website address here in the .well-known directory. It also optionally can be put at the root of your domain name. So we have it as www.apnec.net/security.txt as well. And you can see in here, we have some text that is PGP signed using our GPG key that talks about the contact email address, where to find our encryption keys, and where the policy text is. So people don't have to be browsing around and hunting through our website, finding the vulnerability reporting program text. If they look for security.txt, this will point them exactly to the right location and the email address to be using. Okay, so Now that we've got the reports all set up, ready to go, who's on the receiving end of these reports? So the IT teams will receive the reports into a ticketing system. We already had an email address of csert@apnic.net, but this wasn't publicly used. This was used for internal purposes, for bringing in vulnerability notices from different vendors, putting them into a ticketing system, and then assigning them to other staff. So we really like that email address for being used externally, because of course, security@apnic.net was still being flooded with a lot of irrelevant emails for this purpose. So we repurposed csert@apnic.net. The IT teams will, of course, manage the upgrades of third-party software. So if there's anything with the web server software or the operating systems themselves or anything relating to the network infrastructure, that's their area. They handle the upgrades of that. Now, of course, the question was, well, what about the code that APNIC creates internally? The developers. So we went and were speaking with the different product development teams, and we asked if, can we inject some security patching procedures into your existing development lifecycle? They already had some idea for security patching, but they hadn't gotten a lot of reports because, well, we didn't have a vulnerability reporting program. So it was mostly things that they found on their own, and they just fixed it on their own cycle. So we had to work with them to create a security patching procedure so that they understand about our timelines and how things are being reported and then possibly being made public later on. We also worked with them to impose some timeframes for confirming the vulnerabilities, for fixing the vulnerabilities, testing them, and then pushing into production. So as with any software development lifecycle, there's a lot of stages along things, and confirming the vulnerabilities back to us allows us to reply back to the security researcher, letting them know quickly, yes, we have confirmed this is a vulnerability, we are working on it, so that they know that we're doing some actions and they don't get frustrated and ending up putting it on Twitter before we have a chance to fix the vulnerability. Now, we had a bit of a premature birth. As we're getting everything up and ready, just 5 days before we were going to be publishing the Vulnerability Reporting Program's webpage, a vulnerability report was actually sent to csert@apnic.net. I can't remember exactly when we published the security.txt file, but it could have been because of that. The vulnerability was a stored self-cross-site scripting issue in a display name field. So this was a very valid vulnerability. Didn't have a large security impact, but it was definitely a security vulnerability. Nestled comfortably in the, I think it was a P2 or a P3 issue there. So this was a good early test for our vulnerability handling procedures that we had. We had documented some brief standard operating procedures, but it let us exercise it through, do some updates, and speak to the teams that are actually managing them and see how they thought about the writing of our internal procedure text. And at this point in time, we also added the thank you section, realizing that we were going to be needing that public recognition for them. And of course, we added our very first early bird security researcher for the entry. So a big thanks to Denny, who was our first security researcher for this program, at least. This leads us to the actual birth of the APNIC VRP. So the Vulnerability Reporting Program page went quietly live on the 28th of July. There's the website link there where you can go and view it in its current form as well. And then we went about 5, 6 days later and published the APNIC blog post. Now, this was done purposely very slowly. We weren't sure how much attention it was going to draw. We weren't sure how many security researchers and vulnerabilities they would find. So we did everything nice and slow, and pretty much the only advertising of this vulnerability program was this APNIC blog post that went out. And we had a nice, slow, controlled start, which is what we wanted. We didn't want to overwhelm our teams with brand new procedures, whether it be the IT teams or the security subject matter experts like myself, or the product development teams as well. So for the first 4 months, we had one report each month. So nice and slow, easy, and great time for us to be practicing the procedures and updating them every time that we went through something that was just a little bit different. Now, after those first 4 months, that's where things started going a little bit crazy. Now, the peaks here, there's a couple different ways that we can try and explain them, but it's also a brand new program. So if you look that the peaks are around December and June, if you're thinking about the Northern Hemisphere and schools and universities, those are typically holiday periods of time. That said, a lot of the reports were coming from the Asia Pacific region, so I think it was just coincidental for that. So you can see as the peaks went up, we were getting about 13 or 12 vulnerabilities a month for a couple of the months there. And that was a really big thing. It really stress tested a lot of our procedures, and we had to do a lot of updating on reporting as well. Now, looking at it as a cumulative approach here, so you can see all the green bars at the bottom are carried from the previous slide, and the blue line that keeps going up, eventually reaching 81 unique validated vulnerabilities that came in before the end of 2021. So let's break these down a little bit. So we had on the right-hand side, the priorities. You can see 35 were priority 5. So these were informational, very low level things that didn't have a security impact on us, but were classified as, a weakness in configuration. So they were valid and we brought them in. A lot of P3 and P4 and a smaller number of priority 1 and 2s. Of this, 16 of the vulnerabilities were relating to information disclosure. Now, this could be small levels of information disclosure, maybe giving away a path on a system as part of an error page, or giving away maybe a version number of the operating system. Things that were fairly low level, but things that we didn't want to happen. We had 10 reports relating to reflected cross-site scripting. So that's where it's not stored on our system, but as part of the URL, it can have scripting attacks sent through for the person clicking on a link. We had 5 reports of denial of service. Denial of service was out of scope. These issues were found without causing a denial of service, but they found a weakness that could lead a malicious attacker to cause a denial of service on our servers. So we did allow those reports to come through and thank the researchers for doing it gently for their testing. We got 5 reports of stored cross-site scripting. That's a little bit more serious than the reflected ones. That's where the cross-site scripting code actually gets stored in a database of sorts and can be fed back out. A lot of them were self-based, though. For example, when you logged into a system, your profile may have had a cross-site scripting in it, so it really would only impact yourself. But again, these were valid security issues, and we fixed them up. And we had 4 reports of clickjacking as well, and a lot of smaller numbers of reports. Now, of the 3 priority 1 vulnerabilities, we had, I believe it was 2 SQL injections and 1 sensitive information disclosure. The sensitive information disclosure, this is where it's disclosing information that was a bit more of personal information, things that were not relating to very low-level version numbers. And of course, SQL injection is where you can execute some code onto the SQL database. So that's a priority 1 issue as well. Now, about this sensitive information disclosure, you may have seen this. It is an issue that had then gone public. Now, this is going public through APNIC control. So we went through, we fixed the vulnerability. It was a database that was exposed out in one of the Google Cloud buckets. It was a system that was put in and was a dump of a database that was sort of put there thinking that it was protected, but the configuration was in public mode. We didn't think that any public use had been accessed for it, but one security researcher did find it, and they were able to notify us before any malicious attackers were to go and take copies of the database. So the program actually worked really well in this instance. But of course, APNIC does the right thing. We made a mistake. Information had a very small chance of being leaked out. So we went and were public about what happened, and we worked with the people that were being affected by it. Luckily, it was very well contained, though. Now, looking at who reported the vulnerabilities. So we had 45 security researchers who sent in single reports, 9 researchers who sent in 2 reports each, 3 researchers who sent in 3 each, 1 who sent in 4 reports, and 1 very active security researcher who sent in 5 reports. Now, these reports are based on first reports of unique validated security vulnerabilities. There were a number of vulnerabilities that were reported as duplicates. So these were the same issue reported after the first person. So we received 33 duplicate reports for actual security vulnerabilities, but those 33 aren't included in any of the other statistics. And these were mostly relating to original reports in the first 4 months, as a lot of new security researchers were attracted to the program and coming in. So looking at the lessons that we learned by going through this, obviously vulnerability reporting programs are useful to complement existing security tools and practices. You know, we ran this vulnerability reporting program while we were still getting an external penetration testing company to come in. We were still doing our vulnerability scanning internally as well. So we were still doing all the actions, and we added this on as something extra. We also learned that good communication with internal stakeholders is very important. So this was with our developers and our product teams, and of course, across the IT staff and everybody else, making sure that they are aware and part of the process before the program, during the program, and of course, after the launch of the program, so that we can go back, look at some root causes for these vulnerabilities, work with the developers so that hopefully new vulnerabilities don't get introduced into new code and products that are being created, but also ways that we can improve our own vulnerability handling procedures as well. We also learned that standard operating procedures and response templates help to ensure consistent handling of the reports and the reporters, otherwise known as security researchers. You know, nobody likes having to write out the same type of email, but writing it out by hand again and again and again. So we very quickly took some approved text and we templated it so that the person who is on call or handling the vulnerabilities can just copy and paste and send back quick replies with exactly the message that we want to get across, so that all the information goes across with wording that is being pre-tested to make sure that there's no typos, spelling mistakes, grammar mistakes, or anything else, because we're not sure if any of these messages may end up becoming public as part of a presentation at a security researcher or hacker conference. We also learned that bounties aren't required to launch a VRP. And by looking at those vulnerabilities, you know, for a little over a year, we received 81 unique valid vulnerability reports without paying out any bounties, only putting up thank yous on a Hall of Fame page. So, you know, I personally consider that an amazing success. You know, I would have been happy with a much lower number, but 81 was really great. Now, getting a large number of reports like that, the other thing that we learned is that reporting to our management, internal reporting, gets harder as we receive more vulnerability reports and more details. So that was another issue that we came across. Now, what's been happening since then? At around the 1-year mark of operations, we started comparing the services of vulnerability coordination vendors. So these are companies like BugCrowd, HackerOne, and a few others that are out there. These are companies whose job it is to bring in vulnerability reports, do the deduplication and triaging of them, do the communication with the security researcher, and then pass only the valid stuff on to us. HackerOne was selected for APNIC to receive, validate, and triage the reports. And they also provide some reporting, and they can privately advertise to their pool of security researchers so that it's still small and not overly advertised. Again, we don't want to flood our internal security, IT, and developer teams. And also since then, the triage reports sent to the IT teams are then being routed to the internal product teams. So we've got some better routing, better handling of the vulnerability reports. So also, since the vulnerability reporting program's been running, the VRP page has been updated. HackerOne has a submission form which breaks down the information into different fields and is a lot more formatted than just an email to CSIRT. So we have that as preference to the CSIRT email address now. We've also expanded the out-of-scope list. A lot of invalid vulnerability reports that were coming in, as we got more than one of one type of an issue, we decided to go back and update the out-of-scope list to let researchers know that certain issues are working as intended. So something like FTP Directory Listing. A lot of security researchers will think that we're running an FTP server publicly by accident and we're exposing confidential company documents, but in fact, we're running it publicly on purpose to share public information because APNIC is a very open and transparent organization. We also added in rate limiting issues on non-authenticated endpoints, basically sort of a denial of service, but issues that would maybe send spam emails instead. So some of those issues we closed off, but they don't really have a security impact, so we don't care about those reports as much. And we also don't want reports about missing security flags on cookies that don't relate to authentication. So obviously, authentication cookies need to be protected, and those are valid reports, and we work hard to make sure that they are all protected. But for cookies that don't have anything to do with authentication, again, there really isn't a security impact there. So the security flags fall out of scope. And a lot of those cookies actually come from third-party sites, so it's nothing that APNIC can mitigate on our own. So again, since the vulnerability reporting program has been running for 1.5 years, our thank you list has grown. We had 81 reports, and most of those were individual reports. So we have a long list of security researchers that have been doing the right thing and have helped make APNIC more secure. And of course, APNIC is more secure by running this program, and the proof is in the numbers that we've seen. So that's the presentation. That's everything that I've gone through. Got some chat messages here that I'll go and see if there's any questions. If you do have any other questions or want to have some discussion around this, please put your messages in. More than happy to go through and see how we can discuss. So just let me see what we got here. One sec. So just a question here from Mohammed Andri. I know that CSIRT@ is different with abuse at, but does CSIRT at apnic.net is also being used to report any security incident originating from the organization, since most common email for security related issues is abuse at domain.tld? Or if I rephrase the question, does CSIRT@ act as a catch-all email for any security-related issues, including abuse and vulnerability reports? So really good question. Thank you for that. No, the CSIRT email address is being used for a different purpose. So if you look at the WHOIS records for APNIC's own infrastructure IP address blocks, you'll see that the CSIRT address is not the one listed as the abuse-C or the IRT contacts. So we're separating that out. Those abuse contacts, are a lot of the time not valid. APNIC has, I'd like to think, very good controls over our infrastructure, as well as very good controls and policies for our staff. So the amount of abuse coming from the APNIC infrastructure itself is pretty close to zero. You know, we don't have to deal with the same issues that an internet service provider has to deal with their customers on their IP addresses that could be running up rogue SMTP servers and sending out spam and everything. So APNIC, just as a corporate network, we don't have to deal with that, but we do have kept that separate so that they go to different teams that can be handled separately. So thanks very much for that question. Does anyone else have any other questions that they'd like to ask, or comments, or anything in the presentation that you'd like me to go back and expand on, or anything? So I guess, one of the main takeaway messages from this is, you can create a vulnerability reporting program. It doesn't take a lot of money. In fact, this one was created only using operational time of APNIC staff. Up until the point of contracting HackerOne to do the triaging, we hadn't spent any money on this product or service. So the web page was already there, the ticketing system was already there, the on-call staff with the rotation for IT teams was already there, subject matter experts for security, we were already here. Everything worked really well. A lot of organizations think that you have to be operating as a full bug bounty program. And, if you want to set that as a goal for, a few years down the track, or whenever you wish to reach a certain milestone, you can still offer bounties later on. And if you wanted to, you could even run a bug bounty program separate to the vulnerability program, but for a different scope of systems. So there's a lot of ways that you can build this up over time. And the results that we were seeing here, this was with very small amount of advertising. We could have done additional advertising on a few different websites and programs to get more interest from more security researchers. And that may be something that, if the number of vulnerabilities curves down for us, we may then advertise a little bit more to try and get different researchers looking at our infrastructure from different angles or with a different perspective, finding vulnerabilities that may not be looked at commonly. For example, that buckets incident on the Google Cloud, that was only found by one security researcher because he was looking for that. Other security researchers were looking at HTTP headers or SSL and TLS misconfigurations or SMTP or versions that may have been out of date. So every security researcher looks at things a bit differently. So we may broaden the pool, trying to get more people thinking about things differently. Diversity is very useful in security as well. Excellent. Well, if there's no other questions, I can finish off here. I think Dan can probably put out the message, but I think you can email through any questions to conference@apnic.net after the session. So please feel free to send through questions that you think of after this presentation. More than happy to help you out as well. So again, thank you very much for your time and joining me for this presentation. Hopefully you found this information useful, and hopefully I can connect with you later on if you need any further information or advice in setting up your own vulnerability reporting program.